All right, lesson 1-9 was over understanding scientific notation. So the objective for today is to be able to write quantities in scientific notation and then convert numbers that are in scientific notation back into standard form. So we're going to start with very large numbers and we're going to change them into scientific notation. So Louisa is researching the approximate distance between Earth and the Sun. Her father told her that the distance is 9.296 times 10 to the 7th power miles. In an astronomy book, she found the following: 92,960,000 miles. Which distance is correct? So we're going to start off by finding the first factor that is greater than or equal to 1, but also less than 10. So here's my number, 92,960,000. Okay, this number here is already in scientific notation. Scientific notation is when you have a number that is less than 10 but greater than 1 times 10 to some power. So the decimal point has to come after a number that is less than 10 or greater than or equal to 1. So looking at my number here, the first number that is greater than or equal to 1 but less than 10 would be this 9 here. So I want to put my place value following the 9. So essentially right here. Okay, so I'm going to go ahead and bring down all the other numbers. So 2, 9, 6. And I'm going to count how many times I need to multiply this by 10 in order to get this number that we started with. So if I move my decimal place in between my 9 and my 2, I'm going to have to multiply by 10 1, 2, 3, 4, 5, 6, 7 times in order to get that decimal place moved over 7 times to the right. So this number is written as 9.296 times 10 to the 7th. What do you notice about these two? They're both the same. So the two numbers are correct. Okay, so that's when you have very large numbers. Then we have very small numbers as well. So here we have 0.0000703. We want to write it in scientific notation. So I'm going to rewrite that so we can see it here. I think that's 5 zeros. Yep, 703. Okay, so we have our tenths, hundredths, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millionths place all the way. But looking from left to right, the first number that I see that is greater than or equal to 1 but less than 10 is the 7 right here. So I want to put my decimal point right after that 7. So I need to somehow move this decimal place over here. So 7.03. That's everything brought down from the original there. Now, if I want to move my decimal from here back to where it originally was, we're going to be moving it to the left. And anytime you're moving your decimal to the left, you're going to have a negative exponent for your 10. So I'm going to be moving it 1, 2, 3, 4, 5, 6 times to the left. And because I'm getting smaller here, I'm going to have a negative 6. So anytime you move your decimal to the left, it's a negative exponent. And anytime you move your decimal to the right, like we did up here, you're going to have a positive exponent. Another way to remember it is whenever you're dealing with large numbers, you're going to have a positive exponent. Whenever you're dealing with small numbers, you're going to have a negative exponent. Okay, moving on to example 3, convert scientific notation to standard form. So if you ever see a number like this in your calculator, like Kelly did, whenever you have this E here, this E stands for times 10, and then the number next to the E tells you what power it's raised to. So Kelly used a calculator to multiply large numbers. How can she write the number on her calculator in standard form? So standard form is written without times 10 to the power. It's written as a full whole number. So for this example, a whole number or a decimal. So in this example, we have 3.5. And like I said, E stands for times 10. And then the number following the E tells you which power it's raised to. Okay, so this is the same as 3.5 times 10 to the 15th. Now I'm going to use this to move my decimal. So here's my 3.5. I need to move this decimal 15 times to the right because it's positive, and that's going to give me my new number. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I can kind of fill these in with zeros here. All those place values I've added. And then maybe put some commas in here to separate my number out. So I end up with 3, let's see, millions, billions, trillions, 3.3 quadrillion, 500 trillion. So this is how you would write the number in standard form. Just to write it a little neater, I'm going to write it down here. So I have 14 zeros, 2, 5, 8, 11, 14. Okay. Second example, now we have a negative exponent here. So again, this E stands for times 10, and then the number after the E gives you the exponent. So 10 to the negative 9. So when I write 8, the decimal on 8 is after the 8. Now this negative 9 is telling me how many times I need to move and in which direction. So I'm going to move 9 times to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my decimal. And then I can fill in my place values with zeros here. So my new number would be 0.1, 2, 3, 4, 5, 6, 7, 8. So we have 8 zeros and then the 8. So 0.0000000008. And this is how you would write it in standard form. And those are the examples for 1-9, and that's it.